have one more example in this section to take a look at. Not exactly an example, but some information that we haven't covered yet. And it's about properties. We had done properties, so let me kind of just remind you the 4 basic properties that we went through for addition. They were closure, the idea that if you take 2 whole numbers and the property of addition and the operation of addition, you add them together, you get another whole number. We had the commutative property that said that no matter which order you add them in, they are the same quantity. We had the associative property, which includes at least 3 numbers, and that if you group them together and add them in a different order, that the grouping will not change the sum at the end. And we had the identity property. We talked about the fact that with the identity property, we have to be able to add on both sides in order to say that it's truly an identity element, and it doesn't change the value that we're adding it to. So we're going to look at whole number properties for subtraction and find out which of the following actually hold for subtraction. All right, so look, we're going to go in order. Thoughts on closure. Is subtraction closed for the whole numbers? I did not say that right. Let's try again. Are the whole numbers closed with the property of subtraction? In other words, if I added 2 numbers, it didn't matter what they were, I'm always going to get another whole number. Will that work for subtraction? No. Can you give me an example, Nicole?
3 minus 5.
3 minus 5. Those are both whole numbers. And when I subtract them, I do not get an element of the whole numbers, right? Yeah, I don't. It's integers, which we'll get to in Chapter 5, but we're way far away from Chapter 5 right now. Not whole numbers. How about commutativity? Does commutativity hold for subtraction? No. Can you give me an example?
3 minus 5 is not 5 minus 3.
Okay, so 5 minus 3, which would be a whole number, is not the same as 3 minus 5, right? Which would not be a whole number. They don't give me the same quantity. So no commutativity. Associativity. Hard to know. Let's just try an example and see what happens. You have to be careful when you try examples, seeing whether or not they're true, because if we do find one that works, we have to be careful that it's not just a special case and it only works for that example or a few examples. It would have to work for everything. So we're going to do just an example and see what happens. I have one written down, so we'll go with what I have. Let's take 3, 2, and 1. So 3 minus 2 and then minus 1, and we're going to compare that. So I'm going to put equals, it's a question mark, to 3 minus and then 2 minus 1. So of course, parentheses, you got to go in the right order. 3 minus 2 would be 1, and 1 minus 1 would give me 0. So on the left-hand side, I have 0. On the right-hand side, I'll subtract 2 minus 1 first, and 2 minus 1 would be, don't everybody say it at once, 1. And then 3 minus 1 would be 2. And today, oops, I wrote 3, 2. Today and tomorrow and for the foreseeable future, 0 does not equal 2, right? Not going to work. So these do not equal each other. So since they do not equal each other, the associative property, does it always hold? It doesn't. Now, does that mean we couldn't potentially find an example where it did? Potentially we could. We could certainly try, but in general it's not going to work because we found a case example where it doesn't. How about the identity property? It doesn't. I actually gave this as an example when we talked about the properties last time. Certainly the value 0 almost works, right? It works in one direction, right? Like a minus 0 would be a. And if you don't like the letter A, put 5 in there, whatever. 5 minus 0 is 5, and that works great. The problem is that 0 minus A or 0 minus 5 does not equal A, right? 0 minus 5 would end up giving me a negative, and that would be a problem. So again, there's no identity element either. So we are property-less, at least of those 4 properties with subtraction. Subtraction does not have these same properties for the whole number system that addition did.